Hello, can you hear me now? Okay. So I was talking about the fact that in computer science and programming, we deal with zeros and ones. But because of the level of abstraction that we have, we don't really care about those zeros and ones. All we care about is high level programming, such as Solidity, Python, JavaScript, and the like. So you don't need to worry about zeros and ones. But one thing is that you still need to understand how those zeros and ones work for you to understand some data type in Solidity, especially the byte data type. So when we are dealing with zeros and one, they're always very long because in programming, a bit is just 0 or 1. So if I write 0 now, is a bit. If you have something like 0, it's a bit. If you have something like 1, it's also a what? A bit. So when you have two numbers, 0, 1, that's 2 bits, right? If you have 0, 0, 1, that's 3 bits. So if you have 8 of those zeros and 1, like what you have on the screen right now, we call it a byte. A what? A byte. So 8 bits makes 1 byte. Then another thing again is that having this kind of system whereby you have 0, 0, 0, 0, 0, 0, 0 is too cumbersome, right? So what we can do is that instead of writing it in binary, we can also use hexadecimal format. Hexadecimal format. This is instead of using the normal 0 to 0 and 1, which is binary. 0 and 1 is binary. We have other numbering system. We have decimal, which is from 0 to 9. We have hexadecimal, which is from 0 to E. That E is 15. So 0 is 0, 1 is 1, 2 is 2, 3 is 3, 4 is 4, 5 is 5, 6 is 6, 7 is 7, 8 is 8, 9 is 9. But 10 is A. 11 is what? B. 12 is C. D is what? 13. Then E is what? 15. E is what? Is it 14 or 15? Oh, E is 14. Then we have F, which is 15. Sorry for that. So please, I would like to get real-time feedback from those that are online. So if you have any question, you can always drop it here. And we also have King on the call, which is going to reply in real time. So I'll be talking more on this later on, but for now, let's just know that we have this kind of data type in Solidity. Let's now continue. We have what we call address in Solidity. There was a time we were talking about two types of accounts in Solidity. We talked about the EOA and we also talked about the smart contract account. Those accounts, they have address attached to them, right? So that's when you deploy a smart contract, you get address, right? You get an address. When you create a wallet, you also get an address. That address in Solidity is a data type because when you want to deal with address, you have to tell the compiler that, okay, this is an address. And how do you represent it? You represent using the address type in Solidity. So an address is a 20 byte size or 40 characters representation of the Ethereum address. Solidity has two address type, payable and non-payable. Payable and non-payable. An uninitialized address default to null address by default. I know you must be wondering why is it only A, B, C, D, E, F, and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We only have in an address. Have you ever seen an address with G before? G, Z, or something in the Ethereum ecosystem? You've not seen it, right? That's because the address is represented in bytes. So now, if you look at it now, you can see that each of these you can see that we have 40 characters on the screen. We have 40 zeros, 0, 0, 0, 0, 0 in 40 places. And we said it is 20 bytes. That means each character is how many bytes? That's like half, right? So half bytes, which is 4 bits, right? Are we on track? Yeah. So how many characters? How many characters make a byte? Yeah. How many characters make a byte in this kind of settings? How many characters makes a byte? How many characters? 2 characters make a byte. So this 0, 0, like this 0, 0, 0, 0, 0, it makes just 1 byte. 0, 0 is just a byte. The next 0, 0 is also a what? Byte. So 4 bits per character. Do you get what I'm trying to say? So now those 4 bits is when you want to write it in on screen, you have to use 4 zeros to represent it. Don't worry, I will be doing that later on. But just know that each character is 4 bits. Then when you have the 2 of them, you have what? Two this thing makes it what? A byte, which is 4 times 2. That's a byte. Then I also talked about payable and non-payable address. What's the difference between these two? They are not related to EOA or the SC or the EOA, smart contract account, and the externally owned account. They are not related, but they are just something entirely different. So the difference between a non-payable and non-payable is that, okay, a payable address supports transfer and send. You can send or transfer using a payable address, but a non-payable address will not allow you to send or to transfer to it. And the main reason why we Solidity do that is just to ensure that you don't make mistakes. In your code now, you have some address, maybe you are dealing with address, maybe like the owner of a particular smart contract, and the owner does not need to involve with money or with ether. You get what I'm trying to say? So you can just make it non-payable, right? So when it is involving transfer of funds or money, you use what? Payable. So we're still going to elaborate more on that. But when you know that an address is not going to receive any fund, just make it what? Non-payable. Then by default, all our address are what? Non-payable. They cannot receive money by default. They cannot receive any transfer by default. So sorry, they cannot you cannot make transfer from them, sorry, or to them in the smart contract. Then the next thing again is that we can convert payable address to unit 160 by 20 and also a contract. Don't worry, this thing are just like we still have to come back to this particular slide because it's just like an overview of what we'll be doing. And as I've mentioned before, today is definitely the most complex class of the week, or even like for the next 2 weeks. It's the most complex class, and please don't miss any single detail in this class. It's the most complex class of the week, or probably the most complex class till you will finish this course. And I would like you to pay maximum attention because we're talking about new concepts that are not even available in other programming language like Solidity, sorry, like Python, JavaScript. They're not available. It's only peculiar to Solidity. And now, what's the difference between send and transfer? When you transfer in your smart contract, it will revert on failure. What that means is that when you transfer and it does not go through, maybe you have insufficient balance or stuff, or there's an error, the smart contract will stop executing. It will throw an error. Then every other thing below that line will not execute. And because the blockchain is transactional, which means that if you are doing 4 or 5 things together, and out of those 5, one should fail, every other thing will fail automatically too. Then it will revert back to the initial state. That's what it means for something to be transactional. So now, when you are using transfer and there's a failure, it will revert back. But when you're using send, it will just return false. It will fail silently. It will not stop your code from running. So it's very dangerous. And when you move further a bit, you see that using send at times is dangerous. And this is one of the reasons why they hack most smart contracts. That's why I said this class is very, very important, and it will um, lay a lot of foundation when it comes to understanding what Solidity is all about. The next thing is also, we're also going to be talking about gas, which is when you transfer, when you use the send function, is going to forward 2,300 gas, which is non-refundable. So even though the contract fails or executes, it's going to deduct that 2,300 from your contract. So that's one thing you have to note. Then also this is the syntax for sending and transfer. It looks almost similar. The difference is just the name. Okay, yeah, you have a question. Good morning. You have a question, right? Okay, sorry. Let me come to you. Okay.
Okay, my name is Lukman. You said the gas is not refundable.
Yeah.
So when you perform any transactions and the transaction fail,
yeah,
you have wasted that.
Yeah, it's gone.
So,
But it's little, 2,300 times maybe 0.008. It's very small. So you would not even notice at all.
okay.
It's very small. So don't worry. Although there are times when your smart contract fee that does not deduct anything, don't worry. But this one is just like peculiar to this send and transfer. Okay, is it not 2 character makes a byte? Yeah, you are correct. 2 character makes a byte. You are perfectly correct. 4 bits per character. No. Yeah. 4 bits per character, right? So we have, when you have 4 times 2, that's a what? 8. That's 8 what? 8 bits. 8 bits makes a byte. So that's it. That's why we are. That's why we have it like that. Thank you very much for that question. Thank you very much for that question. So let's move to the next slide. Yeah, an array is a collection of elements of the same type which is used to store data. It can have fixed size, known as fixed size array, or dynamically sized, which is dynamically sized array. You have two types of array: the fixed size and dynamically sized array. In the fixed size array, it's like having a crate of egg. How many egg can you store in a crate? 12, right? 12, 30, depending on the crate, right? You know the number that you can store from beginning. But can anyone tell us how many liters of water you can store in the ocean? Yeah. Yeah, you see, that's just different between those dynamically sized and fixed size. So that's it. One is fixed and one is dynamic. You don't. It continues to what? To grow. So that's it. And an array is just a collection of items of the same type. So now, if you have a crate of egg, right? You cannot store tubers of yam inside a crate of egg. It's not work. So if you have an array of integers, all of them must be what? Integers. Do you get what I'm trying to say? So that's it. Please note that. Unlike other programming language that allows you to store different types in, but so it does not allow that. You either store the same thing or nothing. So then the next thing is fixed. I talked about this one already. That okay, for fixed size array, the type is determined during the compile time. When you are writing your code, that's when you determine the size. Example of such are include byte 1, byte 2, byte 3 to 32. We have byte 4, byte 5, byte 6, byte blah 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 till you get to 32. This byte 32 now. Can someone do like a simple calculation for us? 32 times 8. That should be 256, 256, right? So byte 32 is also equal. It takes the same amount of space as uint 256. Can you say it's a bit like getting tricky? And also, if you notice one thing at the beginning of the class, I said that. Let me go back to the other slide. I mentioned something that it is address is what? Byte 20, right? Is how many bytes? 20 bytes. That's why address can be converted to uint 160 easily. Uint 160 divided by 8 is what? 20, right? 20 bytes. Can you see how it works hand in hand, right? Because you can convert from byte 20 to uint 160 and to address easily. Sorry, it is one way conversion. You can convert from address to this kind of style, but other way around, it is not possible. Do you get? You can convert from address to uint 160, address to byte 20, and address to contract, but it might not be possible the other way around. You get, depending. Do you get what I'm trying to say? It might not be possible. You see where it is possible and where it is not possible when we start coding. So that's one thing I would like to let you know. And also, for fixed size array, the maximum number of items that you can have is 2 raised to power 256 minus 1. That's a lot of number. So don't calculate it at all, please. I don't think your phone can even do that kind of operation. So it's a very large number. Sorry for that. Okay. So yeah, dynamically sized array. The size of array is not predefined. It's continuing to grow during runtime. As your code is run, it's continuing to grow. It's just like an ocean. Do you get what I'm trying to say? It's continuing to grow. It's going to expand. Yeah. So that's it. And in Solidity, you can use byte type to define dynamically sized array. When it comes to strings, Solidity treat them as unbounded array of bytes. As a matter of fact, even string is very similar to byte in Solidity. The difference is that the way they are encoded, strings are encoded as UTF-8. Do you get what I'm trying to say? They're encoded as what? UTF-8. But for byte, they're just encoded as hexadecimal, and you just use them like that. Did you get the difference? So they also, even strings are also what? Like byte. They are convertible to byte. So that's how it works. And let's move to the next thing. You can also create your own custom type in Solidity. A user type can be defined using a struct, an enum, or a contract. It allows programmers to create custom data type that can be used in their smart contract. Do you know there are times whereby the default types available cannot really model what you're trying to build? Let's say you want to represent someone now in your code. You cannot use integer, right? Because if you use integer, it's just like only the age that you'll be able to represent, or maybe the height or stuff like that. But when you want to model the person perfectly, you have to combine 2 or more data types. Like, okay, the height, which is integer, the age, which is also what? Integer. The name of the person is a string, right? The gender, which is maybe male or female. Do you get what I'm trying to say? So that is, so you have to combine all these data types together then to form a new data type, because you can have multiple people in your code and it's not going to be like okay for you to start repeating the same thing many times. So why not just create a type that encapsulates the whole concept of what you are trying to build? Don't worry, we're still going to do the practical, so you don't need to worry about that. So we have the first type is mapping. A mapping in Solidity is a data structure that stores key value pair, similar to hash table, where key is hashed and mapped to a value. So one thing about mapping is that mapping allows you to map key to value. It's just like an array, but there are differences that you see in the next slide. Let's assume that you want to say, okay, like the way we submit all our assignments here is like a kind of mapping. The way we submit our assignment here, we are mapping each person to what? An assignment. Do you get what I'm trying to say? So the key is what? Assignment. The value is what? The real assignment that is submitted. Do you get what I'm trying to say? That's how it works. You are mapping A to what? B. You are mapping the individual person to what? So you are mapping individual to their assignment. That's how it works. We're still going to do some coding. So what's that difference between a mapping and array? The difference between a mapping and array is that array supports length, pop, and push method. So now, if you can calculate the length of an array, but you cannot calculate the length of a mapping. Another thing about mapping is that mapping are initialized by default from A to Z. Like even if the index does not exist, it will return what the default value of that data type. If it is, let's assume we are trying to get the balance of someone from the mapping of balance. If you try to get an address that does not exist, it will still return a particular value, which is what? 0. Do you get what I'm trying to say? If you are trying to get maybe the name of someone and that place does not exist, it's going to return the default null or the like empty string. No, there's nothing like null in Solidity. So that's how it works. So can only another thing again about mapping is that mapping can only be used for state variables, and the reason is because it is stored in the storage compartment, or the location. The location is storage. That's why it cannot be used as a state, as a local variable. Also, we have structs. Struct is a user-defined type that allows us to group different data type under a single name, making it easier to create advanced data types. So now, it's just like a class, but it's a bit less powerful. And what you can use it to do is can create a person, and each person will have a name, we have address, we have all those info. Then you can repeat it, like depending on what you need it for. But don't worry, when you start doing the practical, you will understand it better, because all these concepts are abstract for now. Now the next thing is enumerated type. There are ways to create a custom data, okay, that can be used as a named value. Yeah, this thing is, do you know that yes or no is not enough? There are sometimes maybe you need other status too. For example, now, someone now, if you are registered to a platform, is that you're active or what? Not active. Active or what? Not active. But that does not like apply to transaction. A transaction can be processing, it can be pending, it can be rejected, it can be refunded, it can be a lot of status. You cannot represent that one using what? Bool, right? So you need to use enum for this kind of representation. So enumerated type is more advanced, and it's stored as integers internally. Do you know what I'm trying to say? They store what? Enumerated type as integers internally. They're also what? Integers. So you can convert them from any kind of, you can convert them to any kind of integers. So when we start doing the practical, you see it. Then another thing again is explicit and implicit conversion of types. Explicit and implicit conversion of types. Explicit is direct instruction to convert a value from one data type to another, while implicit conversion occurs without a direct instruction in the code. When you want to do implicit conversion, implicit, you don't need to tell the compiler, it automatically what? Knows what you are doing. Do you get what I'm trying to say? You don't need to like tell the compiler, okay, convert this for me. But when it comes to explicit, you have to what? Convert it explicitly. For example, now you can convert payable address to address. Do you get what I'm trying to say? Without specifying anything, to automatically convert. But the other way around, from address to payable, you have to do that explicitly. Do you get what I'm trying to say? So that's how it works. So without wasting much of our time, let's go to coding. Coding. So the first thing we'll be doing is we'll be opening our Dear Remix, which is a very useful tool for writing smart contracts. Okay, share a window. Okay, new file, which is, let's name this file 4_ bytes dot. So let's talk about byte first. Then let's create another one. Let's name it new file 5 address dot. So okay, we have two already. Okay, so what's the first thing we're doing? SPDX license identifier, which is MIT or anything. What's 0? Okay, let's just go with what we have. The next thing is the pragma, right? Pragma solidity. Oh, sorry, let me remove this one. Pragma solidity. What version of solidity should we use? Let's use 0.8.18. Then we can add this tick to it. Okay, we are good to go. The next thing is let's add a contract and name it byte example. Now, I mentioned something before that when you want to declare a byte, you have to use the keyword byte. But this one is dynamic. It doesn't is like is unfixed. It's not fixed. It doesn't have like a particular size. Do you get? So when you want to use one with a particular size, you can use byte 1, byte 2, which is the first one we'll be experimenting with. Byte 1, byte 2, byte 3, byte 4, and so on and so forth till you get to 32. Now let's do byte 1 first and see what we can do. Byte 1, let's give it A is equal to 0x00. Please note that there are a lot of formats to write bytes to like assign value to a byte in Solidity. You can use this format, which is the hexadecimal format, which is very, very easy and straightforward. But also you can use this format again, x00. You can see that there is no error, right? But this one there will be error. You can see that there is no error. It's still the same thing. Then there's another format again using this encoded this thing. You can use it like this. Now I will tell you the difference later, but just know that those are the 3 ways you can make a byte in Solidity. So let's try to do one thing. 0x00. If you notice, I'm using 0 what? 2 zeros, right? If I change it to 1 0, it will still work. Do you get? If I use a lot of zeros, it will still work because it does not like 0 is still 0. Do you get what I'm trying to say? No matter how many zeros you write, 0 is still what? 0. If like write 0 from now to what? Infinity, it is what? Still what? 0. But the moment you do something like this, 0x1, there will be error. Because this 1 does not really mean what? 1. It's something different to the compiler now. It's in hexadecimal format. So this thing must follow what? The hexadecimal format. This is just a single word. This is like 4 bits. This was 4 bits. It must be something like this. It must be 0x10 or 0x11, 0x12, 0x1f. Do you get? Because each of these things was 4 bits. And that 4 bits makes what? A byte, which is what? Byte 1. Do you get where the names come from now? Do you get it very well? So that's it. And that's why I said this concept is a bit different from what you will see in other programming language. And that thing again about this thing is that we can also do for byte 2. The moment you do for byte 2, there will be error. It has to be what? 4 digits. Do you get? 4 characters. 000F1, F2, FF, or anything you want. Now, why is this 4 bits? Yeah? Why is this 4 bits and not 8 bits and not 10 bits? Let me now give you the explanation, the perfect explanation for that. Why is it 4 bits? Look at this thing in programming. 0. This is what in binary now. You have only one digit in binary. Only what? One digit in binary. What's the maximum number you can represent? 0 and 1. Just two values, right? So this is the maximum you can represent. And this is what? 1 bit. When you have 2 bits, 0, 0, what's the maximum number you can represent? Yeah? You can represent 0, 1. You can represent 0, 0, right? This is 0. 0, 1, 1, 0, and 1, 1. How many? 4. This is what? Awesome. Now, if you have 3, how many can you represent? 8. So now per digit is growing. If you notice there's a progression here, it is 1 digit is what? 2. If you have 2, how many? 4. If you have, sorry, 2 digits is what? 4. If you have 3, how many? 8. If you have 4, how many? 16. This is what? 4 bits, right? This is what? 4 bits. The maximum number of bits is what? This is 4 bits. 1, 2, 3, 4. 4 bits. And there's one thing about hexadecimal. Hexadecimal are what? Base 16. Meaning they have what? 16 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. How many? 16. So the perfect size to represent an hexadecimal number is what? How many bits? 4 bits. Because I have this 16 what? 16 numbers or 16 characters, right? I'm trying to say 16 characters. So now, this one now, since it's hexadecimal format, this one is what? 4 bits. Do you get what I'm trying to say? It's hexadecimal coded, not binary coded. Do you get what I'm trying to say now? So when you have 2 hexadecimal now, beside each other, you now have what? And that was 0, 0, 0, making what? 4 plus 4, 8 bits. So that's why 2 what? Characters makes a what? Byte in Solidity. This is complex, right? You can't find this in any other programming language. So that's why I said don't miss this class. So ask any question. If you have any question, don't okay, Adelu, you don't understand. Yeah, let me try to explain again all over. Because once I explain, it becomes easier. In binary system, everything we do in computing is what? 0 and 1, right? Now let's now assume that we are not working in hexadecimal again. We are not working in decimal. We are working in what? Zeros and 1. When we have just a single 0, how many numbers can we represent with just this 0? 0 and what? 1. Because this is what? Binary. We have just 2 digits. Is that 0 or what? 1. This is very limited, right? For us now scale, we want to represent maybe like from more numbers, we have to add another bit, which is another what? Number. So 0, 0. So if we have 0, 0, how many numbers can you represent with 0, 0? 4, which is 0, 0, 0, 1, 1, 0, and 1, 1. How many? 4. That's why we have 4. If you have 3, you can represent what? Let's count it. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 1. You get what I'm trying to say? I'm not good at counting, sorry, please. So that's why we have what? 8. Then if you have more bits, which is what? Another bit, right? Making 4 bits, right? How many can you represent? 16, right? 16. And this is where this hexadecimal encoded value now comes in. Because hexadecimal can represent from 0 to what? F, which is 0 to 15. How many digits? 16, right? So if you want to encode hexadecimal, how many bits do you need? 4 bits. So that's why one hexadecimal character is what? 4 bits. You cannot use anything lesser. Do you get what I'm trying to say? For hexadecimal. If you use 3, it's not hexadecimal again. It's not work for hexadecimal. Do you get? That's why each of them is what? 4 bits. So when you have 2 of them combined, you have 8 bits. 8 bits is what? A byte. That's why you have what? Byte 1, which is 0, 0. When you have byte 2, it's going to what? Double, double, double. The other calculation that we can do, but I will skip it for now. I will give it as an assignment because I don't want this thing to get more complex. There's something called shift operator. You must have heard it in other program language. It's a very efficient way of dividing values. When you are dividing in maybe like in decimal, it might not be really efficient, you get. But when you take it to bit level, your program will become what? Super fast. You can use what? Shift operator. Go and check it when you get them. So, and I gave you an assignment last week, most significant bit. I know no one can solve that question. No one. I'm very certain, like, no one can solve it. And this is because we've not done anything like this before. And what is the most, what's MSB, most significant bit? There's something called little endian and big endian in programming. Little endian and big endian. It might think it's a very big grammar, but it's not a big grammar. It's a very small grammar. And this is how it works. Little endian. What Solidity use what? Little endian. Solidity use what? Little endian. In little endian, the numbers to the right, they have what? They are least significant. The numbers to the left are what? Most, and it's also what we use in writing daily, every day. That's what we do. So you cannot get that. You cannot get that assignment. You are not meant to even submit itself. So that's why. So one thing is 1,000. We have 1,000, right? So this 1,000 decimal. This is normal number we've been dealing with. Let me do something like this. This is not bit. This is not hexadecimal. This is normal number. Which one is the most significant number here? 1. This is what? Little endian. Because the number that ends is what? The least significant is what? Little. This 9 is what? Little. It ends number, right? Is what? Little endian. But there's another kind of numbering system. There's another kind of system whereby the 9 will be what? The most significant. So now if you write something like this to the computer, so now I mean 9,981 in big endian. But in small endian is what? 1899. Do you get the difference between the two and big endian? So for Solidity, the number at the first, like the number towards the left side, is the most significant bit. Do you get? So now when you have something like this, that's the answer, and we are good to go. Any question? Okay, is there a rule to calculate how many we can represent instead of counting? There's a rule, and the rule is the number of bits, 2 raised to power what? N. If you have one number, if you have one digit, 2 raised to power what? 1, that's what? 2. If you have 2 bits, 2 raised to power 2 is what? 4. If you have 3, 2 raised to power 3 is what? 8. If you have 4 characters, how many? 2 raised to power 4 is 16. 2 raised to power 5, 32, and so on and so forth. That's the formula for calculating it. There's a formula too. Now you get it, Abby? Yes. It's not magic, it's what? Normal rule. Things are getting complex. Bits manipulation, very good. But please, when you get them, go and do that shift operator. It's very, very useful. Like very, very useful. Now let's move forward and do 0, 0. How many bits is this? How many bits? How many bits? How many bits do you have on the screen? 4 plus 4 plus 4 plus 4. 16 bits. Because in hexadecimal, not in this thing. So now let's see. If you do something that's going to bring, like it's going to show error. So it's going to be byte 2, right? So that's how it works. Byte 3 should be what? Something like this. 0, 0. Do you get what I'm trying to say? Byte 4, something like this. Do you get? And so on and so forth. My head won't burst. My head won't burst. Please and please don't miss this class for anything. Don't, even if you go and rewatch it very well, because this is what important and paramount in Solidity. Once you miss it, God, your smart contract will suffer. Don't worry. Now let's move to the next thing. Our dear friend, I mentioned something about um, unbounded array, right? That's one thing about these things that they all if you are looking at it like sometimes you will hear me talking about integer, then from there I will go to byte, then I will go to address, then I will come back to array. They all was related because to the computer they are the same thing. Do you know what I'm trying to say? Let me now prove one thing to you now. See, byte 1, I can put what G and it will still work. This is a what? A string. Yeah? What's 2 raised to power 8? 256, right? I think for UTF-8, how many characters do you have for UTF-8? UTF-8, let's check it online. UTF-8 has how many characters? Let's check it online. How many? 256. Now, you notice one thing, that this Solidity is very easy when you understand how computing works. Not just understanding programming, understand how computing works. Now, the next thing now is that this G now, that's why I said the difference between a string and a byte is what? The way they are encoded. This one is encoded as what? UTF-8. And for one UTF-8 character is how many bits? A byte, 8 bits. Not what? Like the other hexadecimal format. So now if you try to do something like this, GF is going to throw error because you have taken what? The whole space in this byte one like this already. You're just writing this single character. The memory is full already. Are we doing magic here? This is how it works now. Woo. For UTF-8, you have how many characters? 256. Then that 256, someone asked a question that what is the formula for calculating the number of characters for if you are using 8-digit system, right? 8-bit system, 16-bit system, right? And I gave the formula that is 2 raised to power n. Now 2 raised to power n is what? 2 raised to power n is equal to 256. So if you use all these log 2 of 256 is what? 8. So that's why you got what? 8. So we know that what for every UTF-8 character, the perfect bit they are going to represent is what? 8 bits, which is one byte. Do you get? You need what? 1 byte, 8 bits, 1 byte, 8 bits to represent what? UTF-8 characters. So now, because all this A, B, C, D, E, F, G, they are what? UTF-8. So that's why we can what? Use A, B, C, D. Do you get what I'm trying to say? Even that you cannot represent this in hexadecimal, like that 4 bits is not enough. It will throw what? Error. Do you get what I'm trying to say? So that's the magic behind it. That okay, someone asked a question now that is the lowercase or uppercase, does it matter? It doesn't matter, and it matters. It doesn't matter in the sense that if you like use uppercase, use lowercase, to Solidity is what it's still going to take that is what 8 bits. Do you know that A is just this A now is just maybe 000 A, right? Which is can be encoded using hexadecimal, but still it's still taking that what? The whole 8 bits, right? Even though you are using A, B, C, D, it's still going to take that 8 bits. And what about UTF-8 is that small letters and big letters are encoded what? Separately. Do you get? Let's check the encoding for small letter A and encoding for capital letter. You see that they are different. Do you get? So, but UTF-8 is actually what? Two stuff, but Solidity, we're still going to take the same amount. It does not really what matter. That's why you see when we have don't let me go there now. Okay, now so the next thing is let's go to how many encode A, encode letter in UTF-8 online. Let's check it. There's going to be a tool for that definitely, which you can use. Can you see text UTF-8 online that you can use? You can just search it. There are a lot of tools available for this kind of stuff. Okay, I feel you are the only one that understand and some smart ones here. Now only me know they understand. Boss, I know they understand. Okay, don't worry, you will still understand. Actually, just continue with us. You can see this is the encoding, right? 0x61. Do you see? Can you see my screen? Don't worry, please just continue with us. If I say A now, let's say capital letter A and let's encode it. You can see that the encoding distance is different. 0x41, right? For the small letter A, for the big letter A is what? This 0x61. So now for, yeah, okay. Yeah, King is actually taking is taking note of that. Thank you very much, King, for dropping that explanation that in this kind of system. So now this system is not complex. So far that you understand basics of mathematics. Actually, this is what for you. This is primary 6 mathematics in Nigeria. If you're in Nigeria, it's primary 6 mathematics, binary, decimal, and this is primary 6. Primary 6 mathematics. Yeah. No, don't jump. That's why I said no knowledge gains ever what wasted. Actually, you can just go and check this thing all over again. It's not hard. But one thing about me is that I like talking about the technical details. So if you don't know technical details, you can still call your smart contract, but there will be a difference in between someone that knows what's doing and someone that doesn't really understand. Oh, sir, I cannot answer that question. no, let us. Maybe we see past life, we can discuss that one. If you start going there now, it will, it will take a lot of time. So, let's now move forward a bit. For people joining us virtually, don't worry. You can always watch this video again. But the rule is that for byte 1, you have what? 8 bits. For that 8 bits, when you are using this first format, which is 0x, which is hexadecimal, right? Each hexadecimal character is how many bits? 4 bits. So you need 2 of it to make what? 8 bits to fill up this byte 1. When you use byte 2, you use how many? 4 of it. Do you get? So which is what? 4 plus 4 plus 4 plus 4, 16. 2 bytes is what? 8 times 2, 16. It's balanced like this. Please and please take note of this very well. But there's one thing about string. So let's say string now. String. I'll show you some string A. Oh, sorry, string B. We've used it already. Is equal to. See this now. It's not complaining, right? See. No matter how many strings you use, it's not going to complain. So far that you do not exceed what the block limits. You are not going to pay what gas fee. The longer the string, the more the gas fee you pay. So if you have like $1 million to pay gas fee, I'm just kidding, actually, it's not up to that one, Arbitrum. So you just have a lot of money to pay for gas fee. You can continue writing your string. So now the next thing is this is also very similar to byte 32. Byte. This byte without number, this is unbounded, right? It doesn't have like a limit. Let's say C. I'm coming so that people online can also see what we are doing. Let me scroll down like this. So byte C is equal to A, this is not complaining, right? Z is not complaining. Do you see? So it doesn't have a limit. It's unbounded. Yeah, do you get the difference, right? You get the difference between the two. So it's when you want to make it bounded and fixed and unfixed. Yeah, by 2, by 3, or 32. But you can't have by 33, please. The maximum is what by 32. 32 times 8, 256, 256 bits. Yeah? What? It is not by 32, it's more than by 32. By 32 cannot store more than 64. You cannot store more than 32 characters, you get, which is hexadecimal. When it is UTF 8 coded, right? Let me prove it. Let's see. Let's answer that question. Bytes 32, which is D, is equal to. Let's count it, please. Count to me. A, B, C, D, E, F, G, H, I, J. This is J. This is 10, right? 10. This is 20, 30. Let's save it and see. You see, it's still working, right? Let's add 3 more characters. This is what? Complaining. So you can only store what? 32 characters because each of them is what? 8 bits, a byte. Do you get what I'm trying to say? That's how it works. I feel like I've been able to explain from different perspectives, and at least just take one of those explanations. If you want to go really, really low with the bit manipulation, you can still go, but you just want to stay with this approach that, okay, each character is 88 bits, you can go with it. It doesn't really work. So far, you understand what you're doing. I'm good. Okay. Then let's now go to array. Or let's go to address. The same thing we one thing is that you might be coding in Solidity and you don't even need those bytes, except that you may be hashing and all those stuff, which we'll do later. Oh, we'll do in the next class. Function selectors and the like. Okay, so now let's create a new contract and let's name it string example, right? So I'll be dropping this on GitHub immediately so you can reference it later on. Let me go to my GitHub and upload blockchain. Okay. Let me upload it. Okay, why is still loading? Can continue that stuff. So please, if you're online, please you can unmute and ask your question. Don't be shy. You can unmute, ask your question. I'll be happy to take it. The goal of this bootcamp is to ensure that you guys understand Solidity in and out. Yeah. So yeah, please unmute. Let me check if people can unmute. You can unmute and ask your question, please. We still have 2 more minutes.
Hello, guys. Please, I would like to know between the two types of, between the two ways of writing beats, which of them is better to use?
Sorry, I didn't get that question.
I'm asking which is better to use, like when you're writing your code, between the fixed form and the dynamic form
Between what
of
and what?
writing your that. Between the fixed and the dynamic form of writing that, which is better to use?
Okay, it all depends on what you are doing. If what you are doing is fixed, for example, now you are dealing with maybe 2 people, like your smart contract, the sender and the receiver, and you want to set aside an array. So the best thing to do is to use a fixed size array of size 2, like just 2. Then that one is perfect. But when you are dealing with maybe like storing people's balance, and people keep on opening bank account or keep on opening an account with your smart contract or stuff like that. So you can use dynamically sized array. So that's just the difference. That's a good question. Thank you. I hope I've been able to answer your question very well. Okay, King added a lot of codes already online. So please, if you want to check, you can reference those codes. We have code for everything, basically. We have how to convert bytes, a lot of other stuff. Yeah, but I'll still be adding more codes from this class. Please unmute if you have any questions. We still have a few minutes. Adewale Rahim, if you have any question, you can unmute.
I'll revert the recording and any question I have.
Okay, thank you very much. Okay, so since you don't have any question, let's just continue with the address. Wow. So with the address example, while the GitHub is still loading. So if you have an address like this, address, and the address is just a variable, right? You see, it's working, right? This kind of address is what? Non-payable. Let me prove it. Let's say function, then what should be the name of our function? Let's name the function ABC. Then doesn't take any parameter. It is public, and it is just there. Then let's say a dot. Did you see anything like send? It's going to bring error actually. You see, is what? Error. No quick fix. Can you see there's what? There's an error. You cannot send. So what you meant to add was payable in front. You make the a payable address is going to work. And also it's complained that you use what? Transfer instead. So I mentioned that this can also lead to security problem. So you can use transfer instead of send. But if you know what you are doing, if you know what you are doing, you can use that send like that. Do you get what I'm trying to say? But yeah. Okay. Does the send have any merit over the transfer? Yeah. Okay. I can just take that in the case of next time. So the merit is that when you are using transfer, your code will revert. Do you get what I'm trying to say? So it will prevent error, like it will prevent you from making mistake. So if, for example, now in your contract, I something like, okay, the first thing is check whether there is enough funds, right? After checking, then transfer. Let's assume that transfer should now fail. In your send is not going to throw any error. Your code will still continue running. It's going to update all the other logics. So, but okay. Yeah, so let's go to address, and you can see that it's working now. This is different between payable and non-payable. For this one now, address B, it is what? Non-payable. And And the value by default, if you do not assign anything, is the null address, which is or zero address. We call it a zero address, which is 0x, then 0 and 40 places. Do you get what I'm trying to say? So don't let me try and show you the, if you don't assign anything to it by default, it's going to return null. You can say return A. So we can say returns address. Okay, this is a view function because it doesn't change anything. If you notice one thing, that there is an implicit conversion happening here. There is what? There's what's happening here? We did not tell the compiler to convert A from payable to address, and it's still working. Do you get? If we are meant to actually have something like address payable, do you get? But we didn't do that, and it's still working. This is what example of what? Implicit conversion. Do you please take notes? We didn't tell the compiler to convert from address to address payable. We want to make it what? Implicit. So if you want to make it explicit, you can now have something like this. Payable. Sorry, let's have address. Payable. You see what I'm trying? Let's do B. Sorry, let's do B. You see this payable B, right? This payable B is what? What's B before? B is what? Normal address. And we are converting it to what? Payable by doing this. But let me now show you what will happen. Let's assume we have just only B. B. This is not working. Why? Because this address is not implicitly convertible to address payable. You have to tell the compiler to convert it using what? The payable function. Is it a function? A language constructor. There's a payable, then B. This is working like this. That's an explicit conversion from address to address payable. Do you get the difference? But don't worry. For now, we're still going to do it later. But that's just like a very simple explanation. So let's just return address A. This is what we want to do from the beginning before we sit down. So now let's return address A and let's come here and say let's try to deploy. The moment we deploy, we get a smart contract and we can do B. This is what we are getting. We are getting that zero address, and that's because we did not set this address to anything else. Any question, please? There's something called checksum address. Let me show you the difference between a checksum address and an address that is not checksum. Let me show you. Let's say we have address. So this is address B. Oh yeah. And that is working, right? It's also was in hexadecimal format. You can see that it's hexadecimal number. And you can see capital letter A, small letter E, and all those stuff. This is not checksum address again. It's going to show what? Error. This is what I did now. I changed what? Just a single character. It's not checksum again. It's an invalid address. What's the error? Let's check the error we're getting. Invalid checksum. Do you see that? Although it's valid that is correct to us, it's still the same thing, but is what? Not valid to Solidity because the address is not checksum. Checksum is an approach in programming, or we use in error correction and all those stuff too. It's also error detection, not error correction. Error detection. What do you use checksum for? Error detection. That's why when you send an It's already error detection. Error detection is when it detects but it cannot correct. You get. But error correction is when it corrects the error. Do you get what I'm trying to say? There are a lot of error correction algorithms, but we have this one is error detection. Now, the main reason for checksum is that when you checksum a particular value, if the value should change by 1 bit or something, it's still going to like complain. Do you get what I'm trying to say? So let's try to have F here now. See, that value is not correct. Although it follows the hexadecimal principle, but it's not correct. That's why when this will also help us to prevent sending funds to invalid address. So when someone sends you an address, or maybe you scan a barcode and there's an error in the barcode, then maybe your barcode is now reading A as what? As maybe as 9. Do you get? To prevent you from sending money to that kind of address, that's why we have a check sum. Do you get it? Let's move to the next thing. Any question, please? Let's check online. Let's check what people are saying online. Okay, no question online. Okay, someone is asking a question. Oh, you can unmute if you have any question now, please. Okay, let's continue. I don't think the person is asking a question again. Okay. Yeah. Okay, let's go to the next agenda, which is array, right? So for array, you can have. Let's get a new file. Should I drop this on the? Let's drop this on our GitHub. Create a new file again, right? While we're still waiting for the file to be created, let's come here and add a new file. Let's name the new file 6 underscore what? Array. Hello guys, can you see my screen now? You can see my screen, right? Okay. So let's continue. So we have unit 8 and want to create an array of unit 8. One thing about array in Solidity is that they must have the same word, type and size. Do you get? So now let's say unit 8 and we follow it by this square bracket and the name of the variable. This is an array. And what kind of array is this? Is it fixed size or dynamically sized? Yeah? If it's fixed, raise up your hand. If it's dynamic, raise up your hand. It's dynamic, correct? It's dynamic. So if you want to make it fixed, you can just say 5, then it's fixed like this. The size is 5. Any question? Sun is raising up. Okay. One thing is you can say equal to, let me see, 1, 0, 1, 2, 3, 4, 5. Do you see? Hello, do you see this? If it is not complete, it's going to show what? Error. Oh, sorry, it's going not going to show. I think it's over. Let's see when it is over. You see, when it is more than 5, it's going to show error. But when it is not enough, it's still like take it as it is. Do you get? Now the next thing is in solidity, the index starts at where? 0. Index starts at what? Index starts at 0. So this one is what? Index what? Do you get? And so on and so forth. So it doesn't really matter. Just make sure you start from what? 0. So now, how do we do this? How do we now work with this? Let's try to declare another kind of array which is dynamically sized. 8 again, then A, then we don't have a size for it, so we can just what's this? Already, oh, identify already declared, sorry. Okay. Let's now have a function. The name of the function is add to what? Array. What this function does is that from remix, we can add what? New value to our array. Do you get what I'm trying to say? We can add new value to our array. The next thing is to do that, we need to take in a parameter, right? So we need to say uint 8, then what's the name? Let's just give it this one input. If you get, you can name it input anything you want. You can name it A, but we used it already, have you? You can name it C, but it doesn't really matter anything you name it. So far, you've not used it before, no problem. So next thing again is we need to now say A dot, sorry, let's say B dot push, right? Then what do you want to push inside A? You want to push D, right? It's going to be D. Because the way array is like stack, right? You push and you can also pop. When you push, it's going to add to the what? It's going to append. When you pop, it's going to remove the last one. Do you get what I'm trying to say? If you have 2 items already and you push, it's going to what? Add this as the new as the third one. But when you pop, it's going to remove the third one. So that's it. So add to array is this, and let's now say we have another function again, which is a view function, just for us to get the state of the array. Let's just say get array. You can name it anything you like, but this name is just very easy. Let's say returns what? It should return the whole array, right? Am I correct? Let's say uint, I'm coming. Let's do something like this first. Return B. It's going to return the whole of this B, right? Let's now say uint what 8, right? Then this, and it's not going to work actually. You need to do what? Add memory view. You know, I mentioned something the other time that the other time we are dealing with string. I said string because of the way the string is stored in what? In memory. That's why we're adding what? String memory. You do get what I'm trying to say? When you are dealing with array and you want to output array, or you want to use array inside your function, you add what? Memory to it. Do you get what I'm trying to say? That's why we have what? Uint 8 memory. Do you get? This is how to do it. So we are returning what? Uint 8 memory. Instead of saying you are returning what uint 8, something like this, it will not work. You have to put memory after it. We have 3 storage in Solidity: memory, storage, and what? call data. Please make research on that. Storage and call data. Please we're online. If you have any question, drop it immediately. Don't wait till we are done. Okay. So now let's deploy this contract and see how it will behave. Let's go to our deploy and run transaction tab. Let's remove the former contract and let's deploy the new one. The moment we deploy the new one, you can see that we have two interfaces. We have the add to array and get array. If you say get array, now you can see that it's returning what empty array, which is what unit 8. Let's now push. Let's push 1. Let's say add to array. Let's check the log. Let's check the log. You can see that it's successful, right? It's successful. It's successful. Then next thing, let's get array. You can see that is what 1. Let's try to do 2. Let's add to array. Then let's get it. You can see that is what 1 and 2. It's appending. Do you get? That's the push. Let's say 3. Add to array. Let's get array. You see that it's growing, right? It doesn't have a limit. You can continue to append from now to infinity. This is how it works, right? It's just like normal JavaScript and Python and likes. It's going to throw error. It's not going to work. If it is filled already, I'm trying to expand this. How do you not expand this now?
Please, I have a question.
Okay. Yeah, thank you. You asked the question, please.
Why declaring the array unit 8?
Yeah.
I want to know if that 8 affects the elements in the array or that's the maximum size that the array can support.
It's not the maximum number it can support. It's just the individual value. See now, we are dealing with 28, right? What's the maximum number in unit 8? 2 raised to power what? 8. That's 255, right? It's 0 to 255, right? So if you come here and say 255, it's not going to complain. See, 255. You see, it's working. No error. But you say 256, it's going to complain. Do you see? So all the data inside this array must be within the range of what unit 8. So now, in fact, if you come outside, the same thing we did the other time, and we try to append maybe 1,000 to the array, now it's not going to work. It's going to throw error. You see, there's an error here. See, error. Transact to array, encoding value out of bound. Do you get? So that's it. That's why. You can do an array of unit 256. It doesn't really matter what besides it. So far, you are within the rules. So next thing is how to get the length of array. Let's say function get length of array, right? And let's say this one is also a public view, right? Then it returns, what does it return? Returns unit 256, because the length is what? Unit 256. Which is return. What array are we returning? B, right? B dot length. Right? We've added a new function that returns the length of B. This is how we return the length of B, and we can easily come here back and also deploy this new contract. Let's deploy it. The moment you deploy it, you have another interface called get length of, right? Let's get length of. Length of is what? 0, right? Is 0. And let's do something. Let's try to append. Let's transact. We added 1. If you come here, say length of this what? 1. If you come here and append 10, transact. Length of is what? 2. So that dot length gets what? The length of the array, the size of the array for you. If the array contains 100 items, what will be the length of? If the array contains 100 items, what will be the length of 100? Yeah. So that's how it works, basically. If you need to get length of array, you can do it like this. Now do you now delete? How do you delete from an array? You can do what? Pop, right? Which is going to delete the last element. Let's do something like this. Let's copy it. Let's say, no, sorry, let's just have a new function. Let's have a new function. The name of the function is going to be function pop array. Then you can, what do you want to pop? What index? Sorry, there's nothing like index. Public. You say, you see this function is very simple, right? It's just a simple function. They'll come here and say b dot pop. It's going to remove the last element inside b for you. Do you get? Now let's come here and do something like this. Let's try to deploy. And once you deploy, see what? Pop array, right? If you try to pop, it's going to show error because there's nothing in the array yet. So let's try to do what? Let's add 10, add to array, added. Let's add 12. Let's add 13. Let's add 9. Let's add 200. Let's add 102. Let's add 300. Why is it showing this error? You're into what? 8 range. Yeah. So let's just add 0. Let's add 99. You have a lot of items already. So let's say get array. You see, you can get like how many items here? You see, we have a lot of items here, right? So let's just do the get length. What's the length? 8, right? So 8. So now let's now say pop array, pop. It was popped it already. Let's now do get length. It was 7. And let's say get array. 99 is gone. Do you see it? Let's now say pop array again. Array, you see that it's gone. Get array is now what? 6. That's how pop works. Pop remove from the end of the array. But there's another way you can also delete from within the array. You can delete. So let's now have another function. Let's name it function delete from array, right? But before we do that one, let's do something. So you can understand how this delete works. Let's say get array by index. Public. So this is how it works. If you know the index of a particular array, you can get the value. If you know what? Very good. So if you know the index of a particular array, you can get the value. That's what get what? Get value by index. Get array value. Let's say get value by index. Let's just get value by index. So now, for us to do that, we need to know the the index that I want to get from, right? Let's just name it index. Then come here and say returns. So return what? B square brackets. If you put 0 here now, it's going to return what? The index at 0. But I want to make it dynamic so that it is not static. It is not like always 0. It has to be changing. So we can come here and say what? Index. Just replace this index with this index. Then say returns what? Unit 8. It's a view function. So yeah, this is it. Return B index. You can make it this one 0 if you like. You can make it 2, 3, but it's going to be static.
Okay.
So let's try to do this. Let's try to do the static one first. The one that is not dynamic is just static, like, okay, let's deploy. The moment we deploy, we have all the interface, and we have the get value by index. When you click on get value by index, it's going to show error because there's no index 5 yet, right? So let's now start adding to the array. Let's add 18, let's add 17, let's add 12, let's add 44, let's add 200, let's add 198, let's add 330. Let's now do what? Get array. So once you get array, you can see we have different elements on screen. You have different elements on screen, right? 1, 2, 3, 4, 5, 6, 7. Let's do get length. 7, right? We have more than the index now, which is the 5, right? Let's do get index by what? 5. This is working now. What's index 5 in this array? 198. So is index 5 0, 1, 2, 3, 4, 5. Can you see it's correct? It's working. Now let's now do pop. Pop, pop, pop. Let's get array. See, it's gone already. There's no index 5 again. Come here and do a get index 5. It's going to throw error. Do you guys it works? So now for you to now make this more dynamic, so you can define the index that you want to get yourself. You can just come here and say index, then put the index here, which is normal way we do in JavaScript and other languages too. Let's now deploy again. We deployed already, and you can see that there's a parameter. We can put an argument to this parameter now. Let's just put 0 and let's call it. It's going to fill, right? Because there's no index 0 yet. Let's add our first index. It has been added. Let's call it again. You can see it's returning 10. Let's add 122. Let's call it again. Still returning 10, right? Because the index is what? 0. Let's add another value, 12. Let's add 1. We have a lot of items already now. We have like 4. Let's try to get index 2. It's what? Returning 12. 0, 1, 2. Do you get how it works now? So you can get array by index, and you can also pop. And also you can also delete by index. The same way you can also delete by index. Let's come and do this. I'm going to have another function. Let's have another function. The function is called delete array by index. So if you know the index of an array, you can delete the value at that particular index. Public view, sorry, public alone. Don't need any. If it's not view and it's not returning anything, you can say delete b. What's the index? Index. It's going to delete it by the index, and you are good to go. But this is very dangerous. It can lead to security problem. It can lead to a security. This is a very bad way of deleting something in Solidity. Although it's there, but it's a very bad way. And I will show you why now. Now let's do something. This index, let's deploy it again. We now have we have what? Delete array by index. Let's try to add 1. We've added 1, right? Let's add 3. Let's add 5. Let's add 7. We've added everything. And you can say get array. You can see we have 1, 2, 3, 4, 5, everything here based on the get. Then get length of is what? 5, right? Hey, Mr. Dauda, Holy Spirit, stop sleeping. Okay. So now let's say get value by index. What's get value by index? You can do what? 5. It's out of range, right? Let's do 4. Let's call it. It's what? 7. Do you get it? Who is that? I have to meet everyone. I'm coming. Let me try and meet everyone. Okay. Everyone muted. Okay. So the next thing is let's try to delete by index. Let's try to delete index 2, right? Let's try to delete index 2. If it's do index 2, then delete. And I say get array. You can say it's just what? Replace that what with 0. It has been deleted. And when you say get length of again, it's still going to be what? 5. Although you've deleted it, that's one of the security problems that this can lead to. But it's going to just set that back to a default value. It's going to remove the value and replace it with the default value there. Any question? Jesus. Let me put the code on GitHub so that I can have access to this code and experiment when you get home. Return. Okay. Any question, please ask questions. We are free now. We still have 5 more minutes. Okay.
Can you hear me now?
Yeah, I can hear you.
Yes. The question is, as I said that the use of the index for deleting is going to at least going to be a problem as far as
Yeah.
just part of it. So what can we use in place of that?
Oh, that's an assignment. You should check. But I'll tell you about the approach. The approach we do is that the first thing we do is that we grab the item at the end of the array. Once you grab it, you now replace the item at the point where you want to delete. You now replace it with it. Assume you want to delete index 2. Do you get? You now take the last item, then take it to where index 2 used to be. Then now pop. When you pop, you now remove from the tail. It's now become 4. That's the approach.
Let me ask, as you're deleting, you must try and add another value.
As how? You take from, yes, you have 1, 2, 3, 4, 5, right?
Okay.
You take that 5, you want to delete index 2, right? You remove that 2. That's what you want to remove, right? The first approach is you have 1, 2, 3, 4, 5. Let me try and do it on the screen so I can understand. But I will not give you the code. So when you want to delete in a save, we can do 1, 2, 3, 4, 5, right? Want to delete these 2, right? What you do is that you first take this one, you copy the value and put the value here, right? You override this one. Then now call on pop to help you to remove this one. Or better still, you move you do shifting. It's going to be expensive. Yeah. I'm not going to do that. Does that make sense? That's still like better like this than deleting. Depending on the application, sure. Some applications you can delete and it will not cause any problem. Do you get? But depending. I've given you the answer that you need. Is now less way to do the research. Yo. It will still be there. So that's it. It will still be there. It will not go. Let's do the array. So you can check the codes on GitHub. You can check the code on GitHub. You can check it on GitHub. I'm dropping it on GitHub. So in case when you get to, because this week is what very, very filled up. So, but don't worry, it's not as hard as you think. Today is the hardest day actually. Uh-oh. What's up? Is there something wrong with my? Okay. Okay. Let's move on to the next thing. Let's now write a simple struct. A simple struct using this. Then we move to enum. Very quick. Let's do 7 underscore struct dot sol. Then let's copy all our normal boilerplates. These are boilerplates. Let's put it here. Then we can have struct example. So now this struct example, now in this kind of data, let's assume we have person, You can add a struct person, then what are the data that you need to consider? You can say person name. You see, it's just save it will go through. Then the next thing is you can also say um, age, unit. So it cannot be more than 256. So unit text is just okay. Age. Do you get it? This is how you declare a struct. So this is the person and your code, and you can also say that you can use the way you use integers and stuff. You can say person. So this person is not a person in your code now. So we can access the person dot name is equal to this, person dot age is equal to this. Do you get it? That's how it works basically. And let's try to do that. That is having a function. Let's say function, and let me set person. So set person is going to have two parameters, name, which is what string, right? But you know you can have string, memory, name, then uint 256 age. So once you do that, it's public. Then you can now say person dot name is equal to what? Name, right? You can say person dot age is equal to age. And why is it? Oh, you see, what are we getting here now? Why are we getting this error? If you can get it, yeah? What error are we getting now? Someone can just tell us online. Yeah, if you know the answer, you can drop it. Okay, I'm uploading the code already. I allowed you guys to, yeah, you can unmute if you have anything to say. Yeah, why are we getting that error? Yeah, that's it. Unit 8 and unit 256. But if it is the other way around, it will work, but it's not working. So I just change it to what unit 8 and voila, you are good to go. This is it. Then the next thing is function. You can just say function get person, right? Then when you want to get the person, you can say public returns let's say return person, right? Which is the value. But this is what is memory because it's a view function. So let's make it view. And we are good to go. Let's now deploy the smart contract and see what we have. Let's deploy it easily. So when you get home, you have a lot of things to do. Check it out. Now get person. You see that there is nothing. Tuple, not empty string and 0, right? You can see. Now let's now do set person. Let's say hello world is my name, then my age is 16. And just say transact and it's working. Let's say get person. You can see there is what hello world, comma 16. Do you see how it works now? It's just like class in JavaScript, but it's easier and better. Any question? Okay, so let's move to the next thing. We have we still have a lot of things to talk about. We have mapping. We have mapping. I think mapping is last thing, right? Mapping and enum, yeah. So let's go to, let me copy this code and make it available on GitHub so that you check it. Let's have struct example and struct example dot sol and let me commit. Don't worry, we'll still use everything again in another code today. All these things, combine them together to build a fully functional smart contract that sends and receives money. Fonts, okay. Yeah, okay. So let's do this. Let's say new and 8 underscore mapping dot so, right? So for mapping is very, very easy. Is very, very easy, just very user friendly. Let's come here and say mapping example, right? Then we can have something like this mapping. You know, you cannot use mapping inside state, right? You cannot declare inside state. The same with structure too. Inside state is not possible. So inside the local function or a function, you cannot declare it. Sorry. Now let's have a mapping of balance, right? So this thing is not correct like this. You have to make this mapping to map from something to something. You know, this is what we've been doing since morning. We just get unit 256, unit 8, then we put the identifier in front of it, the variable name, right? And if it is an array, we put this in front of it. Do you get? So that's just, but this one is different. You have to add this round bracket here, then say address maps to what? Number in 256. Do you know why? For every balance, you are mapping an address to what? A particular number, which is their balance. Do you get me? So now let's now do something. Let's write a code that does that. Function. Let's say function 1 is deposit. Deposit is we allow anyone to deposit any amount. This is where we'll be using message on sender for the first time. And deposit. So let's say deposit. Let's do the normal method. Address. So the address you want to deposit to, which is receiver. If I'm correct. Receiver, comma, amount, which is unit 256 amount. Those are the two things you need, right? To send money from anyone to anyone. Do you get me? But this function, we're not doing any checking. We're not doing what any checking. Anything goes. If you don't have money, to allow you to send money. Do you get? It's like an open bank. Everyone is meeting their free money, so it's not doing any checking. Just make sure that you come and click on the function, sends automatically. So the next thing is you can just say, it's just like array, the way you do balance, then the round bracket, then, but this time I was the index. The index is address, Abby. So we are going to this receiver is equal to amount, which is this deposit. But you know one thing is that when you deposit, it's not going to just override your balance. It's going to append to your balance. So that's why we use what? The assignment and what? Addition operator. That one you asked about the other time. Plus equal to. Do you get? That's where we now use it for the first time, practically. But it's still equivalent to saying something like this. But I feel like this one is just neater. It's equivalent to saying something like this. Do you get? But which one is neater? This plus plus equal to is neater. So that's why we are using it. So deposit. When you deposit, you increase the balance of the person. The other thing, let's now say get balance function. Get balance. To get balance, you just need to write what the address of the person you want to get. You want to view the balance. So let's just put public and have this and say return, Abby. Return the balance of the what receiver, which is going to receiver. I'm correct. Receiver. Then you have like it's a view function because you're not changing anything. It's going to return something. Returns. What's it going to return? What is the data type that is going to return? You in what? You in what? You in 256. So that's what it's going because this is a mapping of address to what? You in 256. That's the get balance. And This is a very simple bank that we can use. We can also add the withdrawal function, but let's test this one and see what we've been able to build. So let's now go to our deploy and run transaction tab. Let's deploy. Once you deploy, you can see that we have a mapping. So we have a contract, and you have the receiver and the amount. Let's get an address here. Let's copy it. Let's get the balance of the address first. The balance is what? 0. Let's now try to deposit 100 and see what transacts. And you can get, let's get balance now. You see that it is what? 100. It's just simple logic. It's going to store it inside the state variable, this balance. Do you get how we're able to do that? We can also add another function again called withdraw. So everything we've been learning since morning, this is where we are now using it. We are using everything all together now. Withdraw. Then when you want to withdraw, you specify the owner, the amount you want to withdraw from. Then you just say minus equal to this account. Then you now withdraw. Then let's now try to deploy this contract again. We are deploying a new one, and you can see that we have 3 interface: deposit, withdraw, and get balance. Let's try to deposit to this address. Let me copy the address. Let's try to deposit 10. Oh, we are withdrawing. Yeah, the main reason why is failing is because what, you don't have any. You have 0 and you're trying to minus. You get, and this Unity 5 does not support what, minus. It's going to throw error. That's why. Now let's try to deposit now. If you deposit, you can say receiver, then amount, let's say 10, deposit is going to deposit. And let's get balance. Let's put the address. Let's get balance. Is what? 10. Let's deposit one more time again. Let's get balance. Is now what? 20. Let's deposit 119. Is now what? Get balance. It didn't work. Okay, transact, get balance. Do you get? This is how it works, and you'll be able to increment the balance. So let's now try to withdraw, which is minus. Withdraw. You see it's successful. And let's get balance. It's 209. So that's how the logic works. And it's not as this is how to write a smart code. That's how we use mapping. Why are we using mapping instead of array in this kind of scenario? The reason is mapping is more what? Gas efficient. You're not clapping for me. You can actually achieve the same result with what? Array, but you run into another problem in the sense that you cannot index the value of an array by what? Any other thing apart from what? Numbers. So how do you now get the address? How do you get the balance of the address? It's not possible. You get what I'm trying to say now? So now, it doesn't really matter. You can even index by, let's assume we have NFT. Let's not say we have, let's say we have active users. Or let's say we have users in our smart contract. It says it's throwing error now. And this user, you can see that each user maps to what? Each user maps to an ID. Do you get? Which is once you pass in the address of that user, it's going to return the ID of this on-chain. Do you get what I'm trying to say? Then you can also have something like maybe a mapping of index to maybe bool or something, which is doing 256 to bool. Do you get? You can have any mapping to mapping. You can even map from index to structure or struct. Do you get? Index to what? Struct. It doesn't really matter what you are mapping to. Do you get? So next thing now is that we have to move forward a bit. What's the next thing on the agenda? What's the next thing on the agenda? Struct. We've done struct, we've done mapping. Yeah? Yeah? Enum. Okay, awesome. The last one is enum. Let's now say mapping example. mapping example dot. So yeah, you can check the code online and use it as practice. Don't worry. So far that you are with us, don't worry. Everything will come to you automatically. You don't need everything I've been saying since morning. If you don't understand it, this one will make it what clearer. Definitely, we'll start using it in real. Some people, when you explain something to them in abstract form, they might not get it. You get when you do the demo, they will understand better. So let's now go to the next one and do the. Let's create a new file. Let's name it 9. What is it called? enum.sol. So with enum, we are going to add our normal boilerplate, which is this. Let's copy it, bring it here, and say enum example, right? Then let's have enum. When you want to do enum, so just say enum, then the name of your enum. Most times use it for status or stuff like that. Status, maybe like
There is no audio, please. No audio.
hello. Can you hear me now?
Yes, we can hear you now.
Okay. So what I'm saying is that internally, enums are stored as number. So if you try to query this thing, now it's going to return 1 because this is what index 1, this is index 2, so and so on and so forth. Now, what do we do again? Let's try to now combine all this knowledge into a single contract and try to build something meaningful. Our contract is called, let me check it on this thing. It's called a simple bank. A simple what? A simple bank. In this our simple bank, we The assignment we're going to be giving you today is something I expect you to do research on, because the deposit is not going to work. It's only the withdrawal that will work. And the reason why is because there is a modifier that you have to add to your function to make it work, but we will not teach you today. It's an assignment against tomorrow. So it's an assignment. Since you are free to submit all your assignments and then on the week you can learn progressively. Do you get? Yeah. Now the next thing is, the first thing is 10_simple bank. So in this simple bank now, what are the things that you can do in a bank? You can withdraw, you can deposit. I have to give you answers. God, don't worry, I know how to do it. I have to do what? You can check your balance, right? I'll not still give you, I know what to do. Right? So let's try to paste. Okay. Let's come here. Let's copy our boilerplate, right? Simple bank. In simple bank, we have different things that you can do. You can see that the code online might be different from the one that I will give you. But I feel like King is giving you guys exp already if you check the code very well. But don't worry, some people still miss it because I put it very well. So now let's go to the next thing. Yeah, one thing is for us to build these simple banks, we need to consider two things. We need to consider the data that we'll be storing and also the ways we'll be manipulating those data. Now, what are the ways we can manipulate data is deposit and what? Withdraw. They are going to add to the data and also what? Remove from the data. Do you get? Then we also have some view function like what? Get balance of this particular user. And if this user is active or not active. Do you get what I'm trying to say now? Do you get? So now the first thing we're going to do is that we're going to create a mapping to store the balance of each user. We have a mapping, which is a mapping of address to what? Uint 256, right? Then you can say users, right? Let's name it users or account or anything you want, depending on the naming convention. So next now is let's have mapping of this. So let's go for function deposit. What do we do when we deposit? We had money, right? There's no checking. I'm not doing what? Checking. Is anything else go? Anything goes. You get deposit address. Sorry. The address you want to deposit to, right? But we did something in the last class. We did a message or sender, right? This message or sender gives us the person interacting with the contract. So why do we still need to put this address here? You can just get the address of the person interacting with the contract there. That the person is not trying to deposit. Do you get? So we can just have it. Let's remove this and say uint 256 what amount I want to deposit. That's all. That's all we need to know. Then it's what's public function, and this is it. Do you get? That's all you need to do. Then say users message dot sender. Do you get why it is like this? Any question, please? This message dot sender is the address of the person interacting with the contract as of that moment. Do you get? It might be a smart contract too, but this is just the address. Then the next thing is plus equal to amount you want to deposit. And our deposit function is done like this, as simple as ABC. When you view the blockchain as a backend, so when you view this smart as a backend for your application, it becomes more easier. Do you get? Like this is where backend works too. They append and do stuff like that. The next thing is withdraw. When you want to withdraw, what you do is you withdraw from your own account, right? Not someone else's account. Say withdraw. How do you now know the account of the person interacting? Do you get? You can say, user domain or sender, then minus this from their account. Anybody that clicks on the button will withdraw from their account the amount they want to withdraw. Do you get? Now, this function is limited. I would have shown you how to, do this thing. There's something called overloading. It's one of the things we are going to be doing tomorrow. But for now, know that it is possible for two functions to have the same name. It's possible for two functions to have the same name. So, but one thing is that let's not go there for now. Let's just say address, and let's say the owner, or let me see the receiver, sorry. You know, this thing is also the same thing as this. Let's just remove this message and send and replace it. You know, the reason I'm doing this so that anyone can deposit for you. Get, you don't need to just be you doing deposit every time. Anyone can deposit on your behalf. Do you get? But no one can withdraw on your behalf. So that's just different between the two. When you click on withdraw, it withdraws from your account. But when you want to deposit, it says to the account of the person you want to deposit to. So that's just different between these two approach now. Now let's move forward. We'll just have 15 people left in the call. This, wow, people are going already. I think it's the network or something. Okay. Let's try to save this and deploy it. The moment we deploy, we are going to see a new contract. Okay. Simple bank. You have the simple bank, right? We have deposit and withdraw, two functions. The deposit is this. The deposit is this one. If you say withdraw, but do you know there's no way for us to query the balance? Did you notice? Let's add another function called get balance. This get balance can get balance of anyone. Sorry, it should be address. Address. What's the address? Owner. And let's say public returns what? Return users user this is owner, then can close it and fix your returns uint 256. Then it's a public view, right? So this is it, and we are good to go. The next thing is let's just try to deploy. And once we deploy, we have 3 interface, which is the deposit, withdraw, and get balance. Let's try to get balance of this our guy. Is at 0, right? If you try to withdraw $10 now, it's going to throw error because you don't have up to that. Do you get? Then let's deposit some money, 100. Transact, it's working. Get balance is what? 100 way. Then let's now withdraw 10. It is working, withdraw is working, right? Then see what? Get balance is now 90. And this is a simple bank again. We can also have a mapping that we can use to check the status of each user. So we can just say we have an enum, that is what status of this user. There are 3 status, right? Pending, active, and what? Yeah? Banned. Or maybe inactive. Do you get? Then this is another, this is an enum, right? Then we cannot have another mapping again. Mapping of each address to their what? Enum, which is this status. You cannot use users status. Do you get? Do you get? You don't get? Mapping of address to enum. It's just this enum here. We are mapping, instead of mapping it into what? Uint. So what we can do is that, let's say function activates user. Address of user you want to activate, which is the user. Then the name is public, right? Then have something like this. You can now say what? This user status, this the user, right, which is the index, is equal to status dot active. Do you get? So this is when you activate the user. So if you need to ban the user, you can just call this method and say user dot user ban user. But one thing is that we are not doing what? Checking. So there's no way for us to check whether if you are banned, you cannot send money. Do you get? If you are banned, you cannot receive. But I'm just showing that, okay, this is how to implement it on the higher level. So ban user, you can say status dot ban. Do you get? Where is it? So, sorry, status dot inactive. Do you get? So now, with this function now, we can also have another one called function. It's going to be a view function. View get user status, right? Which is also going to be a public view. It's going to return, what's it going to return? Status, right? The status of that is going to return status. And we have return user status. Or you can use message or sender, right? If you are not getting any parameters, you address user. Do you get it? This is it. Or you can use message or sender here. If you don't want to, like, you want to make it get my status or stuff, something like that. So that's how it works. So now let's try to run this code and see what we have. When we say deploy, you can see that we have all the interface ready for us. The first thing is let's try to get the status of this user. Where is it? Get user status. By default, it's going to be on what? 0 on pending. Let's now activate the user and see what will happen. Put the address and transact, then come back and say, get user is now what? 1. If you ban the user, come here, ban the user, transact, and say get is now what? 2. You can reactivate the user here and check it now. It's going to what? 1. So that's how to do the ban. So you can use mapping with what? With enumerated type. And also you can also, you know, this user now is just giving you the status. What if you want to add something more complex? Maybe you want to have a structure that contains the user's account, user's ID, and all those stuff. You can use what? A simple struct. You can say a struct. You can say a struct of user. This is capital letter user, right? It contains the string, name of the user, right? The address of the user. Let me just say account. You can also contain the status, which is status. You can also contain other info about this particular user. So it's now left you to create a function that will now add that user. You can now say function. So before we do that, let's do something. Let's now make this the mapping of address to user, not just address to this thing. You can make it the mapping of address to user. You can now say user struct or something, or better still, you can just name this one balance and name this one users, because it makes more sense like this. So let's just name this one. Let's try and check. So let's give it balance instead of users. Let's rename this. Yeah, we've been able to change all this thing across all channels. Now the next thing is you can now have a function that adds user. Function add user. For you to add a new user, what you do is that you come here, you get all the data you need. What data do we need to add a new user? You need string, memory of the name, right? You also need the address which can get from message or sender. So, but let's just do that one like that. Public, which is this public. Then you can now have these users here. Please take note of this thing very well. User. Then how do you get the index of the user? It's by the address of this user. You can say message dot sender is equal to this user here now. Then open a bracket. Then start putting all the info inside it. See, you can have the name, comma, what thing again? Account AB, which is the message dot sender. Then what other thing again? Status. So the second can be what? Status dot. Let's try to know this. Status dot active. So you see that it's now it's not showing error again. All these one are just they are just there to warn you about this potential. So now, and also now, if you notice that we have what this is an enum, right? It's going to get you an enum, right? This is an enum. See users. Then when you get the index of that user using this address, you can now say users dot status is equal to status dot active. Then this one too, you can say users dot status is equal to what? Inactive. Let's save it and see. If you want to get status, you can say user dot status dot status. Users dot status, which is going to return something like this. And when you save, it's going to save the code for you, and this code is working perfectly. And you can also check it when you get home, or maybe during your time here. Let's try to check it out and see how it works. Did we try to get user? Let's have a new function that get user too. Function get user. Let's say public returns user, which is this user here. Public return user is a data type. It's going to be memory because it is a struct. Then you can say return what user. It's going to return this particular user here. User dot user is a view function. Please take note of that. And in case you can also make it dynamic, instead I can have something like address of user, then pass the address to instead of message or sender. So that's it. And so let's do it. Let's try to deploy this smart contract now, and it's going to show you things that you can do. You can see we have a lot of interface there: activate user, add user, ban user, and all those stuff. So with the proper checking, we can actually check if user is active, then allow it to withdraw and deposit. You get what I'm trying to say? So, but for now, there's nothing like user checking. We are not checking, we're just having the bare code. So what we have now is that let's try to add a new user. Let's try to add a new user. Let me name my name hello world and click on transact. Once you click on transact, it is gone, and let's try to get user. This is my address here. Let me try to get my user and see. You can see that it's returned hello world, then my address and the status, which is 1. That means I'm active. Then if I try to ban myself now, let me ban. If I ban and try to get, you see it is what? It is 2 now. So you can use struct to create more complex data types compared to what integer, string, and stuff can, another stuff can store. Then if you want to do another thing, if you want to activate user, you can paste an activate user, get user back is now 1. So that's how to build a simple bank, and you are good to go. So let's try to add that one to GitHub too, that we can also experiment from when you get them. So the simple bank there actually is the answer to your assignment, but I feel like you guys can just do without it and do something more simple because of time, or you want to take it to the end of the week before you submit your assignments. So yeah, thank you very much, and I will start taking questions now. If you have any question, you can ask. If you have any question, please you can ask. Please unmute. If you have any question, you can ask. Come here. If you have any question, you can unmute. So there's no question. I believe everything is clear, and there's no question. There's no question. If you have any question, you can ask. No question at all. Thank God. Everything is perfectly clear. And I hope you enjoyed the class. So please try to rewatch the video and also go through the slide again. Also try to collaborate with folks. So this is one of the benefits of coming physically. For those of you here, you can easily, show someone your code and they'll be able to give you a response in real time. Please, how can I get the GitHub link? It's on the Notion board. Yeah, it's on the Notion board. So everything you need is there. So for the assignments, we already know already that it's on the board. You can check it out. And bye-bye. Enjoy. Is it in Ibadan? Are you in Ibadan? Is it in Ibadan? Okay. Any other question? Any other question? Oh, you can continue with us virtually. Adewale, you have any question? Oluwani, Oluwapelumi.
I'll reach out on the group if I have any question. This still plenty.
Okay. Okay, no question. Are you serious? Is it clear?
Sir, I'm just managing to understand some things.
Okay.
I will check
Yeah,
the group
trust.
out
Are you
later in
with
the
us?
day.
Hello. Trust, are you with us? Okay. Thank you very much. We'll continue tomorrow. And, yeah.